make it a finer mesh. He said about 20 for every line segment. So on here, I'm going to put a few. And that should be pretty good. Okay.
You are currently the only participant in the conference.
Okay. So now we have our line meshes created, but they're all in the box mesh. So we want to make sure we organize these into the other places. So if we hit return and tools organize, we want to bring these elements here. As you can see, I selected all those. We want to put those into the inlet. That's the inlet right here. We move those. And similarly, these here we're going to put into the outlet. Move. The top and the bottom here. And this one here. We will put into the this one is the wall. Move. And then the body here. These elements we want to put into body. Move. Okay, so now we have our body and the elements of the body, the inlet, the outlet, the wall, and then the box mesh is what we're going to mesh in between. So now it's quite useful to make a box mesh. HyperMesh can do this pretty easily. If you see, we have these tabs here, and normally we're on model. If you go to utility, there is right here a generate 2D BL mesh, which you can click on, and it brings up this menu. And we say you click the add collector button, and it is adding. Try that again. Close. All right, I'm going to save this and try to reopen it. So, CFD mesh. Oh no. Right. Well, let's try this again. Add collector. Okay, here we go. So now it brought up this comps. So if we click on comps, we can tell it which ones we want. We want to select the wall, the inlet, the outlet, and the body. And we say select and proceed. And now it brought up this, it has brought in the components. And he says you can set the boundary condition for each collector, your first layer thickness, layer growth rate, and how many layers you want to create. So I'm just going to set these at the default. They're pretty close to the values that Alan has in here. And we want to make sure we set these values. So the wall, we're actually going to set to far field. And the body we're going to leave at wall. That's a little bit confusing, so make sure you don't get tripped up by that. Body will be set to wall, and wall, which we count as the walls of the top and bottom, are a far field boundary type. And then the inlet and outlet are inlet outlets. And number of boundary layers. Now, for a rule of thumb, you're going to want to have at least 4, 5 or 6 would be better, even more. So we'll do 6. That's probably a good number. And once we're ready, then he says we should also check these 2 boxes. So allow boundary node insertion and allow boundary node movement. And once we have all that set up that way, then we say generate 2D BL mesh. And close this, and here we have just created our mesh. And it's set up so it recognizes as a boundary. And as you see, there's much smaller elements as it comes in here. Here's our boundary layer, and then here are the rest of the elements for it to run. And it'll look a little bit weird like this, but that's just going to happen because these are where the elements are here. Are there any questions up to this point, I guess? Okay. The tutorial actually is pretty easy just to follow along if you just find everything. And if you can't find where a button is, just refer to the YouTube video of this and you'll find out where to click. Okay, so now we want to make sure we rotate this to be in the correct, so it's facing the right way, because right now we have the X direction facing up and the Y direction's this way and the Z direction's this way. We want it to be X, Y, and then Z facing out. So if we go to Tool, Rotate, and we want to rotate all the components and select. And then, so Alan explains that you can click 2 places and rotate it, and click 2 more and rotate it. Really, I just kept rotating it until it came out right. So basically, you just want it to be facing left with the X, Y, and Z. So if I want to rotate this thing, let's see. Probably I'm going to do it along the Y-axis, and I need to set a point, so I'll do it. Do it from there, and I want to rotate it. Let's see. Let's try 90 degrees. I'm trying to think if it's 90 or negative 90. And you say rotate plus, it'll rotate it like this. So now, okay, actually we want to rotate it. Let's do 180. Rotate. And then now if we rotate it along the Z-axis, from that point, and we rotate it negative 90 or 90 degrees and rotate negative, it should bring it down this way. Okay, so now if we click on X, Y, now it's in the correct orientation. We have X, Y, and Z facing out. So we want to make sure we have it in that orientation before we export it to ANSYS. Okay, so now we're going to export this thing. So we say File, Export, and we want to export it as a CFD and solver type Fluent, and then we can tell it where to drop it. So we're going to put it in here. In class, save, and right, and so we just hit export, and it brings up these messages, but I was still able to get it to work. Oh, cancel. Actually, here. So when you click export, it asks, so we hit yes, and then here it says, if this model was loaded from an existing Fluent CAS file, you can use the same CAS file to extract model parameters, blah, blah, blah. So we didn't load this from a previous CAS file. We're making our own new one, so we're going to click no. So would you like to use an existing CAS file? No. It'll just make a new one. So here it's working, and okay, so it created the CAS file. So now we're going to open up ANSYS. So when on the blades, I just go to All Programs, CAD Programs, ANSYS 12.1, and it says Launch ANSYS. Then it brings up this thing here, and so we want to go to right, so you want to go to Tools. If it brings up this black thing, you want to go to Tools, Run CFX Launcher. And this, if I remember right, should bring up what it looks like in number 24. Right, so if you look at number 24 on the tutorial, it shows this guy, which is what we're looking for, which is right here. So now that we have this, we want to set our working directory. So if we go to J drive, choose. Okay, and we click CFX pre 12.1. And it should open another ANSYS. Okay, so we click so File, New Case, and we want to do Quick Setup. Okay, and make this thing bigger. So we want it to be single phase and the mesh file. So we need to import this mesh file that we've made. So if we go to our Lab 13 class. All right, we want to make sure it's not a mesh, but we're looking for a CAS fluent file. So there's our CAS file, and mesh units, yeah, it's fine. So we open that. Hopefully it won't take much longer than this. Okay, so there we go. The view is off. So if we click next until we leave everything else on the default and click finish, and there it's made. It already recognizes this is the inlet, this is the outlet, but we still have to set up a few more things. So we need to set up two boundary conditions. Right, we have two boundary conditions which were set up automatically, being the inlet and outlet. We need to modify those, but we need to create the rest of the necessary boundary conditions. So if we say insert, I'll make this a little bit larger. So insert boundary, and we're going to call this one wall, and we say OK. So the boundary type, we're going to make this one a wall, and location is wall. This is our, yeah. And then for the boundary details, I want to make sure it is a free slip wall and adiabatic. I can never say that word. Adiabatic. Okay, so we hit OK, and it makes that boundary condition, the wall. We're going to make another one, insert boundary, and we're going to make this one called symmetry. And that one will be symmetry, and locations will be primitives. So it should be, there we go. We want it to be the, or actually, yeah, this guy. So it's whichever one is the 2K. There's a lot of these. It should just be this one. So we want it to be these, the mesh that we made. So hit OK, and basic settings, location. Okay, so it should look like, maybe select all of them actually.